So we talked about conduction, convection, and radiation yesterday, and we watched a few videos. So now we're going to look at the effect of heat on solids and liquids. As I said, if you do chemistry, you may find a little bit of overlap with this. You might have done it, you might not have done it yet with chemistry, I'm not sure. So, if heat energy is added to a solid or liquid, it can do two things. It could get hotter, obviously. If you add heat energy, it could get hotter. Or it could undergo a change of state. So it could go from a solid to a liquid or a liquid to a gas. Okay? What happens is, and you'll do this, if you do chemistry, you'll do it in more detail about all the bonds and things involved in it. But when something's changing state, the heat energy is required to break those bonds or make the bonds. Okay, so that's why when something changes state, all that heat energy goes into the bond making or breaking and not into increasing the temperature of it. Okay, so it either gets hotter or it undergoes a change in state. So when it's undergoing a change in state, it doesn't tend to get hotter, it tends to level out a little bit. If heat energy is taken away from a solid or liquid, it will either get cooler, so decrease in temperature, or undergo a change in state the opposite way. Okay, so go from a more energetic state to a lower energetic state, so a gas to a liquid or a liquid to a solid. Okay. So, there's that diagram. Does that diagram look like that in your booklet? There's a little bit missing out here. There's gas here. Yeah. All right. So your booklet's all right. Okay then. Okay. Just a little diagram to show that as you go higher temperature, goes from solid to liquid to gas, and the freezing point is solid to liquid, and liquid to gas is boiling point. Yes, Marie? Very, very, very hot, like the sun hot. Yeah, plasma is another state. There are two other states that you don't need to know about at the moment. One is plasma. Does anyone know the other one? Bose-Einstein condensate. So, but that's like university level physics. But it's another state. So plasma is really, really hot, but Bose-Einstein condensate is really, really cold. So there are two other, but you don't need to know about those. Right, so investigating the factors affecting the temperature rise of a substance. So when heat energy is added to a substance, its temperature usually rises. There are three factors that determine the size of the temperature rise. So can anyone guess what they might be? So if you're adding heat energy to something, can anyone guess it? Oh, the pressure is slightly different. The pressure does affect temperature, but we're looking at sort of like what determines the size of the temperature rise. So yeah, the pressure does affect it, but slightly different. Where? The size of the thing, so the mass, yeah, of the substance. So if you've got a tiny little amount of water and you heat that up, or you've got a huge swimming pool of water, obviously they will rise in temperature different ways. Okay. Anything else? Yeah, the amount of energy you supply. So if you've got a cup of water and you just like hold it with your hand and it'll get very hot. If you've got a cup of water, you put it over a Bunsen burner, you're adding more heat energy. And the last one, Jamie? Yeah, what the substance is made of. So different things increase in temperature in different ways. So plastic is not a very good conductor of heat. Doesn't increase in temperature as much as maybe metals do. Okay? So we are going to do, hopefully this will work, an experiment to investigate the first one. So the amount of energy supplied to the substance and the temperature rise. Okay? So heat energy and temperature rise. You've got a little bit of writing to do. So we're going to investigate how the heat energy supplied to a fixed mass of water affects its temperature rise. So the apparatus is there for you, but the method is you're going to fill the heater with 50 millilitres of water. I've actually done that for you already, so you don't really need to crowd around the taps. You measure the initial temperature before turning anything on. Then you turn on the heater. And then you measure the temperature rise at regular intervals, and I've put C table. So when it gets to 40 joules, you measure the temperature rise. When it gets to 80 joules, 120, 160, 200, and 240. Now it's important that you measure the temperature rise rather than the actual temperature, because that's what we're looking at. So I'll let you write that down, and then I'll go through how to use the equipment. You're probably quicker going to the bottom here. Yeah. Once you've got it written down, if you just put your pens down so I can see. I'll move out the way of the... I can also write in.
We tried one yet.
Sorry?
We tried to do the work.
I've done one of them, but I haven't tried another one. Okay. So I've got a set of results that worked. So in case yours don't work, I've got a set of results. Okay. Has everybody got that written down? Anybody still writing? Right. So to work these, as I said, hopefully it will work. But we'll see. So to work these, what you're going to do is I've put the water in there already. Okay. So you need to first of all take the initial temperature of the water before turning it on. Okay. So just use you should all have a thermometer on your desk. Use that to measure the initial temperature. Write that down. Okay. Then what you're going to do is you plug in. So only one side of the battery is plugged in at the moment. So just plug in the other side of the battery. You also need to turn on the meter at the wall where the plug socket. Okay. Then what you're going to do is you're going to, whenever you want, just press start on the meter. Okay, that should start measuring the amount of energy that is supplied to your water heater. Okay, so once it gets to 40 joules, hopefully they'll work. Then you write down the temperature rise. So you'll need to note down the temperature and then take away the initial temperature from it. Yeah, write that down there. Then when it gets to 80, note down that temperature, but then take away the initial temperature again, because you're looking at the temperature rise from the initial temperature. Is that clear? So you're taking away the initial temperature from each one of those temperatures. So you're not writing down the temperature it gets to, you're writing down the temperature rise from the initial temperature. You don't need to pause it or anything in between, you can just leave it going. So write down what the temperature rise is, leave it going. When it gets to 80, do it again. When it gets to 120, do it again. So it's quite a quick experiment. If you get one full set, then you can repeat. Okay, you can repeat. You don't need to get fresh water. You can go from what temperature it was at originally, so what temperature it is at then, and then just measure the temperature rise again. However, if you want to get more water, you can do, it's 50 millilitres from the sink. Okay, so we'll see how far we get. Might get 2 repeats. We might not have time to do all 3 repeats. Are there any questions? Nope. Okay, well, enjoy. Hopefully it will work, as I said. I have got some sample results to give.